Okay, good morning, everybody. December 10th. Wow, we're getting there. Almost done, huh? Christmas, when we come back, we'll be finished. Okay, so today, what we're going to talk about is proportions in triangles. Okay, proportions in triangles. Proportions, that's a fancy word, but proportions simply means a proportion simply means for us, a fraction equal to a fraction. That's all it's going to mean for us, is a fraction equal to a fraction, okay? Proportional, which means it might be twice as big, half as big, but either way you can hear the fraction, okay? So let's take a look at triangle proportion theorem, okay? So if you look at your book, it says something like this. If a line parallel to one side of a triangle intersects two other sides, then divides the triangle to two sides proportionally. Well, what does that mean? Okay, so what does this mean? So take a look. The big key is parallel. The big key is parallel. Let me go ahead and highlight my parallel lines. So I've got parallel lines here, okay? You have to have parallel lines, okay? You must have, so you have to have parallel lines. And so in this case, I know that QS is parallel to TU. Okay, so if it does that, it really breaks the whole triangle into four parts. Okay, so let's take a look at it. I've got a side here. Let's just call that A. And I've got a side here. Let's call that B. I've got a side here. Let's call that C. And I've got a side here. Let's call that D for right now. Okay, now it just says this. I'll say it. I'll write it. A over B is equal to C over D. That's it. That's a proportion. So we can say A over B, this piece over this piece is equal to this piece, C over D. Or you can even write it the other way. Or you can just say, well, this over this is equal to this over this. That'll work. You can even say B over A, say, or B over A is equal to D over C. Same thing. Okay, now, so let's take a look at this. Find QR. So if I want QR, that's this piece here. I'm just going to call it X. It's just easier if I call it X. I do have parallel lines. You have to have parallel lines to see that. So here's what I have to do. I've got to set this up. Well, I can set it up. I can say X over 3 equals 6 over 4. That's all I do. So I'm going to write X over 3 equals 6 over 4. And I need to now solve for x. Okay, well, if I solve for x, I'm just going to solve. That's x divided by 3, so let's multiply by 3 on both sides. Let's see what I get. So I'm going to get x is equal to 18 divided by 4. Let's see, this 9/2 is 4.5. So QR is equal to 4.5. Boom, there it is. All right, now, the next theorem is basically what we just did, except for they just cut off the triangle. So think about this. They just cut off the triangle. So it's the same thing, but you have to have the parallel lines. So you got 3 parallel lines. I got 1, 2, 3. Okay. I'm going to say the same thing. We're going to say this over this is equal to this over this. Or we'll go, like maybe we'll just say AB. Side AB, we'll go AB over BC is equal to this over this is equal to this DE over this EF. Okay, so they're proportional. This side over this, this over this, this over this is equal to this over this, or vice versa. You can even write it the other way. You can say, okay, well, gosh, how about we do it the other way? I do CB over, I can do CB over AB, same thing. EF is equal to EF over ED, okay? Same thing. Okay, now, let's take a look at it. Okay, here we go. Do I have 3 parallel lines? Yes, I got a parallel line here, here, and here, okay? And if that's the case, then, sure enough, I can, and I want to find HG, let's call it HG. I just like to call it X. Let's just call it X, okay? Let's just call this X, okay? Makes it easy for me. Unknown. It's my unknown. So, let's set it up. This over this is equal to this over this. So we can write as x over 120 is equal to, be consistent, x over 120 is 300 over 150. Okay? Don't mix it up. Be consistent. This over this, this over this, okay? To solve, that's divide by 120, so I'm going to multiply by 120 to solve it. Multiply by 120, and I'm going to use my calculator. I'll just show you because I'm going to make it easier for myself. I'm just going to, okay, well, let's just make this easy. Clay, let's go 300, cancel, sorry. Let's go 300 times 120 divided by 150, and I get 240. I kind of thought so. It looked like it was, twice as big. So I would say this side, HG, is 240. Okay. Hopefully this seems pretty easy. The book goes over it as well. You'll see the 3 parallel line theorem. They say the exact same thing. Okay, good. Okay, now last theorem to talk about today has to do with the triangle angle bisector. So I thought, okay, well, let's just do an angle bisector. Now, we have not done this in class because we're not in class, but if you did an angle bisector, here's how it works. The pokey thing right there, I'm going to draw it, okay? Draw it with a compass. It's called a compass, okay? What I get is an intersection here. Let's call this A. An intersection here. Let's call this B, okay? Now, taking my compass again, and this time put it on A. I'm going to draw an arc on the inside, and I'm going to draw another arc on the inside with B, okay? From B, same thing, okay? And what I get is a third point. Let's call that X. Now, the bisector, then, of the angle has to go through that point X. Okay, here it is. Right, there you go, right? Okay, there's my angle bisector, okay? Now, here's what I know. That's my angle bisector. Let me draw a triangle. So down below, I drew a triangle, okay? So what does this theorem say? Let's check it out. This theorem says that if you have a triangle bisector that, let's put it up, let's give you ourselves A, B, C, D. It's going to say this side, or this piece, over this side is equal to this side over this side. Okay, so on my drawing above, I could have drawn a triangle. Go ahead and just draw my triangle in. Okay, let's draw my triangle in. You guys will see it. Here's my triangle. There's my triangle. And this is what we're going to say. We're going to say that this piece right here, okay, so let's call this A over B, C over D. We're going to say this piece over this piece, A over B is equal to C over D, or vice versa. You can say, okay, B over A, it still works that way. B over A is equal to D over C. Okay, if we know that, if we know that's our theorem, then what I want to do with that is actually figure it out. Okay, so here we have it. I know it's an angle bisector because I see angles equal to angles, so that's an angle bisector. Okay, we need an angle bisector. You have to have the angle bisector. Okay, so then I want to find TU. I'm just going to call it X. It's always easier for me to use X because it's the unknown. So let's do this. Let's go X over 48. X over 48 is equal to 14 over 24. Okay, the piece of the base is equal to its side equals the piece of the base over its other side. And then I'm just going to solve for X, so I'll multiply by 48 because that's divided by 48. So I'll multiply by 48 both sides. Again, I'll probably use a calculator. Well, that goes in 2 times 28. I can do that in my head, actually. Goes in 2 times. 2 times 14 is going to be 28. Okay, and that's the value of that side. Okay, so please do this. We are going to have a test on Monday. Test Monday. Because we're done with this chapter. We'll review on Friday. We're going to have a test on Monday. Okay, that's it. That's all I have. Okay. And we'll see you in Zoom.